Evaluate the triple integral over e of x minus y dv, where e is enclosed by the surfaces z equals x squared minus 1, z equals 1 minus x squared, y equals 0, and y equals 2. The limits for z are parabolic cylinders. And if we identify, say, z equals x squared minus 1 as a blue one and z equals 1 minus x squared as a green one, then it's left to us to figure out which one is the upper limit, which one is the lower limit. Let's look at the trace in the xz plane. Z equals x squared minus 1 is a parabola that opens up and is 1 unit down on the z-axis. And z equals 1 minus x squared is a parabola that opens down and is 1 unit up on the z-axis. We can therefore see that our inequality should be x squared minus 1 is less than or equal to z, which is less than or equal to the green one, 1 minus x squared. Looking at our y limits, we can see that y goes from 0 to 2. What I'd like for you to do now is sketch the region in R3 and set up the integral. Come back when you have the setup done. Here's the solid. We have the upper parabola, parabolic cylinder, I should say, 1 minus x squared, the lower parabolic cylinder, x squared minus 1, and then y goes from 0 in the back to 2 in the front. That leads us to our integral, which is going to be the integral. I did this as dz dx dy. You could have just as easily done it dz dy dx, because those limits are both constant. It's really easy to change those around. But the way I did it, I have the integral from 0 to 2 of the integral from negative 1 to 1 of the integral from x squared minus 1 to 1 minus x squared of x minus y times dz dx dy. If you did do this as dz dy dx, totally fine. Go ahead and do it that way. But either way, I'd like for you to go ahead and compute this integral and then come back again when you're done. For our first step, integrating with respect to z is going to give us a factor of z, and then evaluating that with an upper limit of 1 minus x squared and a lower limit of x squared minus 1 gives us the integral from 0 to 2 of the integral from negative 1 to 1 of the quantity x minus y times the quantity of 1 minus x squared minus the quantity x squared minus 1 dx dy. And the 1 minus x squared minus the x squared minus 1 becomes 2 times quantity of 1 minus x squared. Our integrand is then x minus y times the quantity of 1 minus x squared, and simplifying that and rearranging the terms gives us the 2 is out front times the integral from 0 to 2 of the integral from negative 1 to 1 of x squared y minus x cubed plus x dx dy. Now at this point I'm going to point out that the negative x cubed plus x, they're both odd terms. And as far as x is concerned, our interval is symmetric. It goes from negative 1 to 1. A symmetric interval with odd terms is going to evaluate to 0. So those actually are gone. And integrating what's left, we end up with 2 times the integral from 0 to 2 of 1/3 x cubed y minus xy, where x is going from negative 1 to 1 dy. That gives us 2 times the integral from 0 to 2 of 2/3 y minus 2y dy, which is negative 8/3 just by combining like terms and then multiplying by the 2 out front, times the integral from 0 to 2 of y dy. That evaluates to negative 8/3 times 1/2 y squared evaluated from 0 to 2 for a final answer of negative 16/3. We say, wait a minute, how can it be negative? Well, nobody said it was volume. As it turns out, our integrand, x minus y, goes negative inside of our region. A negative answer for a triple integral, totally fine. It just doesn't have a physical meaning in the same way that a positive would. Same instructions for the next one. Our integral is the triple integral over e of z dv, where e is bounded by the cylinder y squared plus z squared equals 9, and the planes x equals 0, y equals 3x, and z equals 0 in the first octant. I'd like for you first to set up the region D in the XY plane, and then see if you can sketch the region E in R3, and set up the integral. Come back when you're done. Well, I've got my setup here. Let's see how we did. We have the line y equals 3x, and it was maybe tricky to know what the upper boundary would be for that, but if we take z equals 0 and combine it with the equation x squared plus z squared equals 9, then we see that y would equal 3. It's plus or minus 3, but we're in the first octant here, or first quadrant for this picture in R2. We have a choice to let either x or y have variable limits. I chose y. We can see in this region y is going to go from the line y equals 3x, so y goes from 3x to 3, and x goes from 0 to 1. Now, translating that into R3, well, we don't translate that into R3. In R3, that's this triangle here in the xy plane. But now we have this cylinder, y squared plus z squared equals 9, and that's just a straight tube, right? Tubular cylinder, and it's being sliced by the vertical plane through y equals 3x, and so we have part of an orange wedge. I don't know. It's a wedge of some sort anyway. Maybe it's cheese or something non-food if you're hungry because you haven't eaten yet. Now, z goes from the floor, the xy plane, up to the cylinder. So z goes from 0 to 9 minus y squared in the square root, right? Y, we've already decided, goes from 3x to 3, and x goes from 0 to 1. Therefore, our integral is the integral from 0 to 1 of the integral from 3x to 3 of the integral from 0 to 9 minus y squared of the integrand z, and we picked the order dz, dy, dx. You could have just as easily picked the order dx, dy, but then you'd have to solve the equation y equals 3x for x, and then x would have variable limits that depended on y. Integrating this should be pretty straightforward, so let's just go ahead and take care of it, where you've got the integral from 0 to 1 of the integral from 3x to 3. We're going to end up with a 1/2 z squared when we integrate with respect to z. Evaluating at the upper limit is going to give us 9 minus y squared. Don't forget the 1/2. Evaluating at the lower limit for z is going to give us 0. So now we have 1/2 times the integral from 0 to 1 of the integral from 3x to 3 of 9 minus y squared dy dx. Integrating with respect to y is going to give us the integral from 0 to 1 of 9y minus 1/3 y cubed, and that's going to be evaluated as y goes from 3x to 3 dx. Putting 3 in place of y is going to give us 27 minus 1/3 of 27, so 27 minus 9, 18. Putting 3x in place of y is going to give us 27x minus 9x cubed. So we have 1/2 of the integral from 0 to 1 of 18 minus the quantity of 27x minus 9x cubed dx. Integrating with respect to x gives us 1/2 times the quantity of 18x minus 27 halves x squared plus 9/4 x to the 4th, evaluated from 0 to 1. The arithmetic there is going to give us 27/8 as our final answer.